Hey Chem family, today we are going to be learning about a solubility chart which will eventually help us determine after a double replacement reaction whether the products are aqueous, meaning they're still dissolved in water, or if they're insoluble, meaning they came out as a solid, or if nothing really happens, if this compound never happens at all. So we're going to learn how to read this chart, which will help us eventually predict products. So get ready, let's go. Looking at this chart, if we look at the left-hand side, you'll notice that there is a bunch of metal cations like aluminum, ammonium, barium, etc. All right, and then also the anions are at the top. Things like sulfate, phosphate, nitrate, iodide, some common anions, all right? But you notice in between that there's a lot of I's and S's and X's. So what do those mean? Well, first of all, when these two come together, meaning the cations and anions, they're either going to form a compound that is soluble, which means that in the water it will stay, so it's aqueous, all right? So soluble means that you won't actually see it in the water. It'll just stay there in its ion form. If they come together and the chart says that it's an X, it either means that it decomposes or it doesn't exist, that those anions and cations don't come together. And then at the top here, if you get to the I, that means nearly insoluble, which means a solid, meaning that if it's sitting in water and that compound comes up with an I, it means that it's going to be a solid. So it's going to be sitting at the bottom of the liquid, okay? So you'll actually be able to see it. Let's jump into some of the formulas and figuring out if it's a solid or it doesn't exist or if it's aqueous. And then from there we can kind of get the hang of it. All right, so first thing, let's look at the compound name and name this first one. Mercury 2 chloride is the compound. So let's write the formula for that. Well, mercury is Hg2 plus and chloride is -1. So coming together, you would make HgCl2, right? In order to actually write the formula. Now, the question is, will this compound, after it reacts and is formed, will it be aqueous, solid, or not exist? Well, it's simple. Just use the chart. For mercury, which is right here, and for chloride, which is right here, we would then see where they meet, which looks like right here. So, if you end up with an S on the chart, the S stands for soluble, which means if it's soluble in water, it dissolves, so it's aqueous. So even though this compound might form, you actually wouldn't see it. It would be dissolved in the water completely. So we would call that AQ for aqueous. Let's look at lead 2 iodide. Lead is Pb2 plus, and iodide is I -1. So when you bring that together, that one would be PbI2. Okay, so now we have the compound formula, but now let's look at lead and let's look at iodide and see on the chart where these guys meet. And lead 2 iodide ends up being an I. I stands for insoluble, which means that after it mixes and reacts, if it's formed, it would stay a solid in the water solution. So therefore, it would be insoluble. We would actually see it. All right, let's try one more example because I'm sure you're going to get the hang of this pretty quick. Let's look at number 6, iron 2 carbonate. All right, iron is Fe2 plus, and carbonate we know is CO3, and that overall has a 2- charge. So iron 2 carbonate would end up being FeCO3. Now, let's look at iron 2 on our chart and carbonate on our chart, and coming together, carbonate would be I for insoluble. Insoluble means that it doesn't dissolve, so that means in a liquid you would see it as a solid floating around or sitting on the bottom. All right, so this has been an introduction to the solubility chart. Now, we will eventually use this to figure out, after we have compounds mix in a double replacement reaction, we'll be able to predict whether the compounds, the new ones that are formed, are going to be aqueous, meaning that they're dissolved in water, or insoluble, meaning they'll form a solid, a precipitate, that will eventually just sink to the bottom. And again, something good to mention, a precipitate is after a reaction when a solid falls out of solution. So in water and liquid, it might look like a snow globe, powder or something that's falling to the bottom. That's an insoluble solid. Anyways, this is the beginning steps. Hopefully it's a good understanding and starter, and let's start applying that to double replacement reactions. Have a great day, Chem Fam. See you later.